we were looking at the function f of x equals x squared plus 1. And so now what we're going to do is we're going to increase that a little bit. So when we looked at the domain of x from 0 to 2, we found that when we broke this up into 4 rectangles, 2 rectangles per unit, we found that the sum of the areas of the lower rectangles to be 3.75 square units, and the area of the upper rectangles to be 5.75 square units, and then the average was 4.75 square units. So then we used the graphing calculator, or TI-84, and so in order to help us with the calculations, we decided to use it because we're looking at larger numbers of strips, larger number of rectangles that we're going to be breaking this area up into. So what we're going to do is take the TI-84 here, and because we want 8 strips, that's what we're going to do is we have the domain, which is 0 to 2, so it's 2 units, and we're dividing by 8 strips, or dividing it into 8 rectangles. That means that each rectangle is going to have a width of 4, or 1/4 of a unit. That's going to be the width of each of our rectangles, and then from there we can input the values to get the sums of the areas of each of those rectangles. So we'll turn this on, and then we'll go to second stat, and then we'll go over to math, down to 5, which is the sum, and then we'll do second stat again, and then we'll go over to operations and go to 5, which is a sequence. And so now we want the expression. The expression is actually the actual area, which is length times width, that expression. We'll put the width first. We'll put the width being 1 over 4, because that's the area of each strip, or the width of each strip that we're looking for. And then we're going to multiply that by the function, because now we're trying to find the height of the function, or the length of it, I guess, so that would be x squared plus 1. Okay, so that's the expression that we're going to be using. That's the length times width, or width times length, as we input it here. The variable is going to be x, and for the lower rectangles we're going to start at 0, because that's the left bound of the interval, and we're going to end, because we're dividing it up into quarter unit widths of these strips, we're going to always be 1/4 away from the end of the 2 unit interval. So because we're using the lower boundaries, or the lower rectangles, that means that we're using the upper left vertex of the rectangle as it sits against the curve, and so if each rectangle is 1/4 of a unit wide, then we will end up being 1/4 of a unit away from this upper bound, because the width of the last strip, again, just like all the other strips, is 1/4 of a unit. So we're going to end up at 7/4, because it's the whole width of the strip is 1/4, and we're going to be on the left side of that strip, because that upper left vertex touches the curve. And the step is going to be 1/4, and we just paste that all together, and we get 4.1875 for the lower area. Okay, so now we want to find the sum of the upper areas. So I'm just going to do second enter, and that brings me back into this calculation again. And now instead of going from 0 to 7/4 in this interval, I'm going to start at 1/4, because now we're using the right side right edge of these rectangles, because we're going to line up the upper right vertex of each rectangle with the curve, which means these are upper rectangles. So I'm going to start at 1/4, and I'm going to go up to 2. Still the step is the same, the variable is the same, and the expression is the same. And now I just press enter, enter, and I get 5.1875 square units for the upper area. Okay, so I've got the lower area and the upper area together, and then I'm going to average those to get 4.6875 square units. Okay, and then I'm going to further divide this interval into smaller width strips, into more rectangular strips, so that it'll get a more accurate or a precise estimate. So I'm still, now the width, now in this case, the width is still, or the full interval is 2 units, and we're breaking it up into 20 rectangles, so the width of each rectangle is going to be 1/10. Okay, so I'm going to second enter. Now I'm going to have to back this up. So the step is now going to be 1/10, and then now because I already have this 2 here, which corresponds with the 2 at the far right of the interval, I'll just leave that on there. I'll calculate the upper areas first. I'll go over here and I'll put in 1/10, insert 0 here. So I'm going to start at 1/10 because the rectangular strips are 1/10 wide. That means I'm starting on the right edge of the first rectangle, because the upper right vertex of that rectangle will correspond with the curve, and then I'll have a chance to get the upper areas, and then I'll change the width to 1/10 as opposed to 1/4, which we used before, and so we get 4.87 as the upper area. Okay, and then I'll do the same thing for the lower area. I'll second enter. So everything else is pretty much the same. I'm going to, instead of starting at 1/10, now I'm going to start at 0, and then I'm going to go up to 19/10, because I'm going to go just shy of the 2 unit boundary on here, and then I just enter, and we get 4.47 square units, and then take the average of those and you get 4.67 units. Okay, and then we do this again and we end up getting, so for 50 strips we end up getting 4.5872 square units for the lower area and 4.7472 for the upper area, and the average there is 4.6672. So notice, so we could do this again. We could go up to 100 strips if we wanted to, and then do this again. Notice that the lower areas are increasing, 3.75, 4.1875, 4.4, 4.58. The upper areas are becoming smaller, 5.75, 5.18, 4.87, 4.74. So we see that the lower areas are increasing, the upper areas are decreasing, and they tend to be converging to a value. And here's the average, 4.6672. It seems as though they're actually approaching 4.66. So if we use more strips, we would be able to verify that. Okay, so that is to finish off the example that we had started before.